Okay, so when we're looking to graph or write an equation, of a graph of a parabola, one of the things we have to do is find a. Now, a is the leading coefficient. That is the number in the equation in vertex form that stretches the parabola. So we're looking for how is the uh, parabola been stretched or compressed. And we do that by comparing the vertical distances in the parabola we're given to the parent parabola. And I want to show you this illustration we worked on in class. Remember, our parent parabola has vertical distances of 1, 4, 9, and 16, and so on. Every horizontal distance is squared. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on, because we're looking at a squared pattern. So when we compare these vertical distances, we might make ourselves a table and say that we have our horizontal distance, or our over, and then we have our parent parabola. What does that do? What does that do? It goes up. And then this one here. Okay. So we'd say that our parent parabola, we look at where's our vertex, here's our vertex. And then we find another point and we say, oh, here's another point. So we see that the over here is 1, over 1. The parent parabola usually goes over 1 and up 1, up 1. But this one goes down 2. So the way we transform a parabola using a leading coefficient is by multiplying the vertical distances. So we basically take this number and we say, what times a, this times a, gives us negative 2. 1 times what gives us negative 2? Well, you can see it's already solved for us. A is negative 2. So in this parabola, the vertical distances are negative here, and they are twice as far. So instead of going up 1, we go down 2. Okay, let's take another one. We can see here's the vertex, and let's find another point here. And we can see that the other point that we can identify is this. So in this case, going over 1, it gives us this here, which is we could guess at, but it's hard to tell where exactly that is. This one looks like it's very clearly on a grid line here. So once again, over the parent vertical distance, and this one. So we can see that this is over 2. The parent parabola, when we go over 2, we check our reference, over 2 up 4. So parent parabola would be up 4, but this one, you can see, is up only 2. So once again, we say, what would we have to multiply by times a would give us this vertical distance of 2? 4a equals 2. Well, solving for a here, we would divide both sides by 4. And we'd say a equals 2/4, or 1/2. So this is a parabola where the leading coefficient a is 1/2 because the vertical distances are compressed, or they're half the usual length of the parent. Last example. We can see that there aren't many clear grid lines here, but we do see a point that is right on this grid line, and there's our vertex. So in this case, we went over 3. We know that the parent, when we go over 3, we go up 9. So this one we have to count and go 1, 2, 3, 4, 5, 6. Oh, my mouse squiggled a little bit, but this one is 6. So that means 9 is what we normally have for an over 3, for a horizontal distance of 3. You're going to multiply that by a to get 6. So 9 times what equals 6? Just follow the same process. Divide both sides by 9, and we have a equals 6/9, or in this case, or I say in any case, when we have 6/9, we can reduce that to 2/3. So those are 3 examples of how to find